Hey guys, so today we're going to be discussing introduction to database schema design. This is something that you guys will be doing a lot, so let's go over the basics. All right, so just to back up a step, let's actually talk about why we need databases in the first place. So databases are very useful. They provide a lot of features to software developers. One is the ability to store application data between sessions. This is known as persistence. So for example, if you log on to Facebook and you create a post, you would expect that next time you log on, or if you log on from a different computer, that you would still be able to see that post that you created. And obviously, the way this data is maintained would be via a database. Um, Another reason databases are useful is to share data between applications. So for the same example, if I put a post on Facebook, I would expect that my friend would be able to see it when they log in. So that data would be shared via a database in the backend. Staying with the Facebook example, databases are great at efficiently handling large volumes of data. This is somewhere where CSV files can fall kind of short. I know a recent example that was talked about in our SQL presentation was tracking COVID data. For example, I believe data was being stored in a CSV file or in Excel, and the limitations of Excel was that it did not show beyond, I think, 64,000 records. So it actually truncated the data and led to some unexpected results, I guess. And then, yeah, another feature that databases provide is better data security and integrity. So again, comparing it against CSV files, you can set up authentication and user logins with databases, whereas doing that with CSV files isn't so common. So if you have a CSV file, it's very easy for someone to access and manipulate. But going off of the integrity portion, again, CSV files are primarily text-based, so you might have a typo, or you might be putting in the wrong data, whereas databases kind of protect you with that if, again, the key thing is if they're designed correctly. So that's where database schema design comes into play. All right, so yeah, moving on, let's talk about what your design goal should be when you're designing a database. So one thing is you should definitely be thinking about organizing your data into sensible tables. Again, I guess this is kind of similar to going back to our discussion about designing classes. You want to have modularity. So you don't want basically everything nested into one data table. That's probably not a good design for your database. You also want to make your data easy to access. So for example, this is maybe going in the other direction. You want your data to be separated in non-sensible ways. For example, if I were storing like a person's name in a database, I wouldn't want one table for a user's first name and like a different table for a user's last name, because that data is usually going to be accessed together. So it would make sense to have it in separate tables and kind of have to access it through multiple tables. Modeling proper data relationships is a very important part of, I guess, the integrity of your database. This is where, like, for example, if I'm a user of Facebook, like my user should be mapped to my profile, and there should be like a direct link, so that you don't have like profiles that just belong to users that don't even exist in your system. That wouldn't really make sense for Facebook's standpoint. But yeah, sorry about that. You also want to reduce duplicate data and redundancies. So this again goes back to our class designs. If you find yourself writing like repeated code, that usually is a bad sign, and that usually means that you can condense your code into a better, sensible design. And that holds true for databases also. Like, you don't want to be storing your data, multiple data records or data, I guess, in different tables when they're actually the same data. For example, if I have a users table, I wouldn't want to have like a user profile table that also has user information. It should link directly to the users table rather than copying that data. So yeah, reducing duplicate data is key for proper database design. All right, so let's talk about just the general steps when you're about to create a schema design. Step one, and maybe the most important, is actually think about your design. So I know this was mentioned in a past lecture that your design should be well thought out, as in you don't want to be changing it often once it's implemented. Occasional schema updates or schema design updates throughout your life or application's lifetime is, is possible, but you don't want to be like updating your schema every day as your application changes. That would not be making your database administrators very happy. But yeah, once you've thought of a good design, you want to start by creating your entities. So this is just your data models. For example, if we're using the Facebook example, we'd have users, we probably have pictures, probably have posts, various other information organized into different tables. Once those entities are established, then you want to proceed to creating relationships between those entities. So again, this is where the integrity part comes in, where you want to reference stuff from other tables to make sure that a valid user exists for your profile or photos that are uploaded. You don't want to just I guess have IDs or names that aren't really referenced. For example, if a user leaves Facebook, then that profile shouldn't be orphaned. It should there should be strong relationships. So if the user doesn't exist, the profile should also not exist. All right. So again, think about your design, create the entities, and then create the relationships between your entities. So again, it always helps to see an example. So let's actually use the example that's on the curriculum page. So let me get over here. So I'm just going off of, that's not today's data. So yeah, going off of the curriculum page, we have a Facebook example. So in this case, we're going to model users, posts, comments, which are, I guess, comments on posts, and then replies will be on comments. So I guess we have various levels of text data that we can create. So yeah, let's start modeling this. So I guess the thought part has been kind of done for us. We don't have to think too much about it. We have information that we need to model. So let's get to modeling this. So to create a visual representation of my schema, I'm actually going to use quickdatabaseddiagrams.com. So this is a pretty handy site. It's really easy to kind of just get up and running with this. So I already have a page open here. So let's start creating data. So I'm actually just going to copy this over and start editing. So in my editor here, I can kind of just write the fields in. So my ID is going to be a primary key, so we'll talk more about keys shortly, but we have that. And then we have names, so this will be a varchar, let's say 64 characters. Profile URL, so a photo URL, let's say that's a longer varchar, let's make that up to 255. And then bio, so this also would be a varchar, I believe. Giving proper data types here. Let's make that 256 also. Maybe make that a little bit more. All right, so again, as I type these fields in, I get this little box in my visual area. So it's kind of nice to see, like, I can see the details. I can see that my ID is my primary key, and we'll kind of get to messing around with this once we're creating our relationships. But I just want to create my data right now. So I'm going to create a post entity. So let's continue typing here. Let's just assume post can be max 1024. User ID will be a foreign key. So I'll do the docs for that. So let's see. All right, so we need to give it type. Then it's going to be and that would be users. I gotta check my syntax there later. We'll talk about, again, foreign keys, primary keys, what they mean, what they're used for. Just want to just create my entities quickly. So maybe I'll leave that up. It's all capitalized. All right, so comment will also have an ID. So as you notice, each table has an ID. It's usually best practice to use IDs as opposed to using the actual data as your primary keys. content will also be and finally we'll have our replies. Copy that, move that over. All right, so I think I have my entities created. I have 4 in total right now. I have users, I have posts. I'm going to add another field here. Email, that bar, char, let's say 1. All right, so I added email field. Hopefully we'll use that in a bit. All right, but I have users, I have posts, I have comments and replies. So, again, this is just from our curriculum page. Now that I have my entities, they look pretty good right now. It's time to create relationships. So my users are going to be the one actually creating posts and creating comments and replies. So each of these tables already has a user ID, but currently the way we have it right now, these user IDs don't really mean much. Like, they could be bogus values. They need to actually reference actual users. So this is where, having the users table, having an ID, and then creating that connection. So I'm actually just going to draw a connection from here to there. All right, so now I have this connected. So user ID actually references the ID in my user table. So I'm going to actually do that for comments. And not sure why I can't do multiple. So actually, I need to actually drag it the other way. So that's my bad. So you want to do it from your referencing table to the table that's being referenced. All right, so my user IDs, again, are mapped to my user table. But then we also have some inner relationships between our posts and comments. We have a post ID that references post ID. And then let's fix these out a bit. We also have a comments ID for replies that reference a comment ID. So right there. All right, so these lines are kind of getting crisscrossed, but hopefully it's pretty clear. All right, so I have these relationships set. Again, the IDs are referencing the tables directly. So this is going to be, if I don't have a comment, then I can't have a reply on that comment, which kind of makes sense. All right, so let's talk about keys in database. So we created these links, but we actually need to give our tables some primary keys. So if you notice, when I created these links, it actually updated my code here. So we created foreign keys. So foreign keys are basically keys that reference keys from other tables. And let's actually talk about keys right now. All right, so there's 3 main types of constraints that you can have in a database. One being primary key. That's where we talk about often, so hopefully it's familiar right now. But primary keys are a key that is the main identifying data for your table. For example, if you have a user table, you would have a user ID, usually as a primary key. Again, it does not have to be an ID, but best practice is to use an ID. So for example, if I need to look up, user 45, that 45 would be the primary key, and it would give me all the other data that I need for that actual user, whether it be name, email, whatever is stored in that table. So primary keys must be unique, as in you can't have 2 records with the same ID. You can't have 2 users with ID 45. And then every table in a relational database actually needs a primary key. Right? And then we have another type of key, which is unique keys. Unique keys are very similar to primary keys. They're a key that enforces uniqueness, as one might guess. The difference between a primary key and a unique key is that you can have multiple unique keys in a given table. However, you can only have 1 primary key per table. And then lastly, as we kind of mentioned, foreign keys. Foreign keys are simply a key from one table that references a key from another table. Now, that key that's being referenced could be a primary key or a unique key, for that matter. All right, another thing, important thing to keep in mind is that keys can actually be made up of multiple columns within a table. So I forgot to add some columns here, but yeah, multiple columns, plural. And these are known as composite keys. So you could have simple keys, which is reference, one column in a table, or composite keys, which are two or more data columns that represent your key. And we'll try to see an example of this shortly. All right, so these are your three main types of constraints that you can have. So let's go back to our diagram. As I said, we need primary keys. So the ID, I need to add PKs for that. Okay. And for each of those, I get a nice key symbol in my table, so I know that's a primary key. But let's talk about something else. So one thing, like for Facebook's, you have a login. That login can be your email, and so we actually want your email to be unique. So in this case, email needs to be a unique constraint, but it's not going to be a primary key, as in our primary key is going to be our ID. So in this case, we could type in unique here, and that's going to add a little small key next to email, meaning signifying that it's a unique item, as in we can't have two different records with the same email in our users table. All right. So let's actually talk about types of relationships now. So going back to your slides, the types of relationships you could have between two tables, the base ones are one-to-one. So this is where you have one data table referencing another data table, and each one of those are like singular in terms of the relationship. So for example, each Facebook user can have one and only one profile page, right? So this is a one-to-one relationship because one profile maps to one user. You can't have multiple profiles for one user, and you can't have multiple users using the same profile page. So that's a one-to-one relationship. One-to-many is, as the name would imply, one entity can have many, instances of a relationship with a different table. So easier way to say it with the example is each Facebook user can have multiple different posts that they can create, right? So I, as a Facebook user, can create 5, 20, 30, as many posts as I want. But a post can't have multiple authors. So like I can create a post, but there can't be a post that's just created by two different users based on a Facebook model. You can share posts, you can include like people's names in the post, but there's only one true author. So that's an example of one-to-many. We have one Facebook user, but that user can have multiple different posts. However, a single post cannot have multiple different users as the author. All right, and then the last one we're going to talk about is a many-to-many relationship. So this example would be expressions. So again, just going back to our curriculum page, expressions are just likes, thumbs up, or whatever you want to call them on Facebook. But posts can have many different expressions, and then the same expressions can be used for many different posts. So for example, you can like 20 different posts and give it the same expression, or the same post can have many expressions from different users. Right, so that's an example of a many-to-many relationship. Okay, so let's actually convert this to code. So quick database diagrams actually makes it kind of convenient. You can go to export. I'm going to click export here. And notice it gives me a bunch of database options. So we're using Postgres, so I'm just going to click that option. It's actually creating a file for me. Looks like I'm missing a field type at 11, which is not good. Thank you for checking my work. All right, so now that all my relationships and field types are correct, I can save this file. So I'm actually going to save this. And then I'm going to go to my VS Code and get that file. So let's see if I can have some trouble here. There we go. All right, so as we can see, a lot of the SQL has been created for me. So one note I just want to mention right now, anytime you're either copying code or in this case, I guess having code generated, I always want to say that you should know what the code is doing. So you definitely should give it a read. Don't just assume it's correct. Definitely don't copy code and just paste it without knowing what it's doing. Again, that's not a good way to learn what the code is doing. That's a good way to know how to copy and paste, which isn't the skill we're trying to teach here. So again, in this case, this code was generated for me, which makes it a little easier, but I still should take the time to make sure like everything looks correct and make sure I understand what everything is. So I'm looking at this. I have, I have a primary key. So in this case, it's creating the constraint after creating the field. Usually we can just type in primary key here, but this works as well. So we have a constraint of primary key. We have a unique constraint. So I guess they use UC as the prefix. I usually see UQ. But in this case, that's the unique constraint that we added for email, since each user should have a unique email. Then we have our post table. Again, primary key on the ID. Likewise for comments and replies. So after these tables, we have all of our foreign keys that get created. So it's, you want to create your tables first before creating relationships between the tables. So in this case, these are all of our foreign keys that will be created. Right, so this looks pretty good to me. I know usually we like using serial keyword here. So I think it's just serial. Actually, I should look this up. So let's read some docs. Right, so we can include the serial word. All right, so I'm going to do so I just need serial primary key. So I'm just going to modify my code. So again, generating code wasn't quite what I wanted. So this might be an issue. Let's get rid of this. So again, serial just auto increments the ID for me, so I don't have to specify each time, which generally you want for your primary keys. So I'm just going to add that in there. All right, so those are our 4 tables. And yeah, everything looks good to me. So let's actually try running this. So I'm going to go to my terminal, bring that up here. Okay. First thing I need to do is create an actual database. So to do that, I run the create db command for Postgres, and I give my database name. So let's call it Facebook schema. Let's call it Facebook for now. All right, so no errors. So I think that worked correctly. And then let's actually add this data in there. So to get that to run, so one way I could do this is I could type in SQL, use my database name, which is Facebook, and then use the caret sign to kind of feed in the data, that SQL that I want to be in there. Again, alternatively, I can type in all the SQL into pSQL, but since I already have it in my file, it makes sense. I'll just do that. So I think I do that. Oh no, I got some syntax errors. Never good. It's serial is the problem. A couple times. All right, that sounds good. Clear that. So also, usually best to drop table if exists. So this is the case, like I believe my users table probably got created since my error was later. So I need to so sure I have this correct. And cascade. So if you guys aren't familiar with the cascade keyword, you usually want to include this when you're dropping tables. This forces data that's referenced in this table to also be relinquished. If you don't have this, you might have trouble dropping your table if some other table is referencing like your primary key via a foreign key. Right, so that's for each table. All right, sorry about that, guys. I had to fix some errors. I had some extraneous commas that were kind of getting my SQL into some issues. But all right, I made the necessary fixes. So again, I added my drop table statements with the cascade keyword, which again will allow me to drop this table even if other data records are referencing this table. Then I create my tables and then finally create my foreign keys. So let's actually give this a run and see if it works. All right, so I'm gonna type pSQL, then my database name, and then I'm just gonna feed in this file. So it's Facebook schema SQL. All right, so I get a bunch of output statements, no errors, so that looks good. And then if I actually want to look at my database, so I actually installed an add-on in VS Code, a Postgres SQL add-on by Chris Coltman. And that just lets me actually view all my databases. So I have a bunch here. This is the Facebook one that I just created. So in this case, there's my tables that I have, comments, posts, replies, and users. All right, so let's actually extend our example to kind of incorporate a many-to-many relationship so we can kind of see how that works. So let's go back to my database diagram. All right, so we have our schema set up as such. Let's add expressions as another entity. So I'm just gonna type here expressions, and it's gonna be a simple table. It's gonna have an ID int, that's our primary key, and then we're gonna have a type. So this will just be, say, a varchar 32 characters, and then we're gonna have one more table. So again, this is a case of many-to-many. So whenever you have a many-to-many relationship, you likely are going to need to have a, I guess, a join table or a through table, because we can't really map many-to-many relationships with just having our two entities as is. So we'll see how this kind of comes together. So for my join table, I'm going to name it posts expressions, and this will have an ID, which will be my primary key. Then we're going to have post ID, and then an expression ID. Right, and these will be foreign keys. So let's drag this table over here. So this table is going to sit in between my post table and my expression table. And then this references the ID here. And then my post ID is referenced as such. All right, so now we have this join table with a post ID, which references the post table, and then an expression ID, which references the expressions ID. All right, and we probably also need a user ID for the expression. Let's add that in there. User ID. And that's also going to reference user table. All right, so definitely a little more complicated, a lot of lines crisscrossing here, but hopefully this still makes sense. Again, we created this through table so that we can map a many-to-many relationship between post and expression. And the reason we need this because posts can have multiple expressions, and then the same multiple expressions can be used across different posts. For example, you could like 20 different posts, or 20 different people can like your own post, right? So, all right, we have this table. Let's generate the SQL for it. Save that file. I gotta go find it. Let me actually rename it so I can try it in here. So I have my file. I'm gonna drag that into VS Code. All right, here we go. So Facebook schema 2. Again, we'll look over by changes. see that I have additional tables created here and appropriate foreign keys. So let me add back these. All right, so just copy that. Much easier. All right, so how many tables? And my drop statements for all my tables. Bear with me for a moment here. All right, that these comments. Our new tables, we have expressions. Posts, expressions. All right, so we have all of our new tables. Let's give this a run. Hopefully we have no errors. Let's keep that 2. And we begin there. Oops, sorry. Oops, some errors. Let's see here. That. Right. I think that should be good. All right. I think that worked. No errors. Great. Doing my terminal. All right. So let's think about one more idea here. So we have our post expression table. However, I'm thinking about adding a constraint. So if we think about it, based on the Facebook model, the same user cannot add 2 different expressions to the same post. Again, this is possible in Slack or maybe other platforms, but as far as I know in Facebook, you could either like a post or heart a post or frown on a post, but you can't add multiple expressions for the same post. So let's actually think about how we might model this. So this is where a unique key will come into play. So if you want to actually add a unique key, we'll alter table. And then in this case, it's going to be post expression. And again, this actually made an instance where we're going to have multiple columns that are going to be unique. Because again, a user can have different expressions on different posts. And also, multiple users can have the same expression on the same post, but the key constraint that we need to add is that a single user can't have multiple expressions on the same post. So I'm going to add constraint. We're going to give this a name. So let's call it UC. Copy some of this. Expression ID. Say unique. And then let's actually be multiple columns. So add the columns in here. So we're going to do this in order. So we want user ID and post ID to be unique in tandem. So we're going to do user ID and just like post ID. All right, I think that's the syntax for it. Let's give this a run. All right, let's get to the docs then. Postgres, alter table. All right, again, documentation. Postgres has really good documentation, so let's find our here. Alter table. Alter table. So maybe I just don't need to keep here. Let's try that. All right, cool. So we added a constraint again, as we talked about, our user ID and post ID in tandem should be unique. We don't want the same user being allowed to have multiple expressions on the same post ID. So this constraint should protect us from that. So again, this is a case where we have a key that uses multiple columns, not just one. And again, just highlighting our menu-menu relationship, we created a intermediate table, also called the join table or through table. This kind lets us have a case where we could have a post that has multiple expression IDs or use the same expression IDs across different posts. Again, that's mapping our menu-to-menu relationship. All right, so this is our simple Facebook example. Again, it can get complicated. Again, even this wasn't as simple, especially when we look at our diagram here. We have a lot of lines connecting through various tables. Just imagine, if we have 40 different tables, these diagrams can get very complicated. But with that said, I hope you guys have a good time with database schema design. And as with everything, with more practice, you guys will get better at it with time. All right, thanks, guys.